Hello everyone, this is day 23, question 2 of our Leetcode activity, design circular DQ. Design your implementation of circular double-ended queue, that is DQ. Implement my circular DQ class where my circular DQ int k initializes DQ with maximum size of k. So this is our constructor. Boolean insert first front adds an item at the front of the DQ. Return true if successful, false otherwise. Insert last adds at the rear of DQ. Delete front deletes the front. Delete last deletes the rear. Get front returns the front. Get rear returns the rear. Is empty if it is empty, true, otherwise false. Is full, it's full, then it's true, otherwise false. Now, first of all, you need to be thorough with the logic of what is a circular DQ, or first of all, what is a DQ. So DQ is double-ended queue. That is, you can add from the front or the back and also delete from the front or the back. That is, you can also insert front, you can insert last, you can delete front, you can delete last. So suppose I want to add something to the front now. Where should I add it? So for that you should know front always points to the front or the first element, front element. So if you I want to add anything to the front, suppose I add it here, then front should move back, not forward. Front should add the value one index behind the current front, so it should move back. Now rear, if I want to add anything to the rear, it should be added one index front of the rear. So rear will move forward when adding at the last, and front will move backwards when adding at the front. This is the logic of DQ. Now when it's circular, it nothing means, it just means that the last and the first element are joined. So if suppose a rear is here and this last element is open, then once things are added, front will wrap around the whole thing and point at the last element because this is available. That's it. So that is the circular thing. Or in the same way, if rear reaches the end, it can also wrap around and come at the first element. So that is the logic of circular DQ. How we will solve this? So we will declare some variables for our convenience and for our use in this solution. First of all, a vector, we have initialized it with the name q. So this is the vector where we will store our values. Front, I have already defined front and rear. Size is the number of elements currently present in our queue. Capacity is the maximum elements which can be present in our queue. So my circular DQ int k, q vector int k. So that is, we have resized our q and initialized it with k size. That is, we resize it to fit maximum of k elements. Size is 0 because of course right now the queue is empty initially. Capacity is k, that is maximum value. Front is 0. So front will point the first index, zeroth index. Rear is not 0 but k minus 1. K minus 1 is the last element or the last index. Now why k minus 1? So previously when we designed circular queue, we initialized rear to 0 because rear used to point to the index where the next element should go. But here rear points to the rear element or the rear value at the back. So why k plus 1 though? Because you will see this in insert last thing. So when you will see here rear insert last is full return false, that is not our concern right now. Okay, rear plus 1 modulo capacity, that is right now rear is k plus 1, k minus 1. So k minus 1 plus 1 is k modulo k is 0. Why k modulo k? Because capacity is k. So k modulo k is 0. So it will at last wrap around to 0 when the first index will be added. So here we have initialized to k minus 1. Now insert front. If full return false, that is there is no place to add, we can't add. Front. Front minus 1 plus capacity modulo capacity. So what this is doing is, I have discussed this. Front should move one index behind. Of course, it should move one index behind. So here it is front minus 1. Why is modulo capacity? Modulo capacity will always keep it in this our defined range. It should not go to minus 1. After 0th index, it will go to minus 1. But that is not a valid thing. It should wrap around to the last element. Then again traverse whole thing, come to minus 1 and wrap around to the last element. That's why we are using modulo. But modulo, there is property or there is a logic. Whenever you want to apply modulo to a something minus, you should also add uh, the value by which you are going to apply the modulo. So in general, so suppose my current was 0, I did minus 1 and directly did modulo k. So let's suppose k is 5. So it will become minus 1 modulo 5, which is equal to minus 1. And that is not false. That is not true because minus 1 does not exist. But we are not getting the value which we needed, which was 4. We want 4 here. So to solve this problem, what we have to do is firstly add the capacity or the value. So 0 minus 1 plus 5 modulo 5. This will be 4, as minus 1 plus 5 is 4. 4 modulo 5 is equal to 4. And that is 4 is our last element, index of the last element. So we have successfully wrapped around our front directly to the last element. So this is the logic we will use, that is front minus 1 plus capacity modulo capacity. Now we have got the value, we have got the index for front. q front is equal to value size plus plus because we have successfully added a element, so the size increases, that is number of elements in the queue increase, and return true. Now insert last. I have discussed for rear, front moves back, rear moves front. So rear plus 1 modulo capacity, that is if rear is at the last element, last index, so that it is at the fourth index. So when it goes to fifth, phi is not a phi. If the phi is maximum capacity, phi is not a valid index. It should wrap around to 0. So for that, if it is 4 and it has go to, it will move forward. It will go to 5, but we have to wrap around it to 0. We'll simply just modulo 5. That will give us 0th index. So for rear, the logic will be rear plus 1 modulo capacity. Once we get the index, q rear is equal to value size plus plus because we have successfully added our value. The number of element increase, size plus plus, return true. Now if you want to delete front, now here the logics will swap. Because now I want to delete front, so when I'm adding, I'm moving backwards. But for deleting, I have to go forward. So we'll just simply do front plus 1 modulo capacity. Size minus minus because we have deleted a element. And yes, also we have to do a sanity check, that is it is empty. If the queue is empty, then we have to return false because there is nothing to delete. And also delete last, same, first check if it is empty. If no, now for rare adding we are going forwards, so for deletion we should move backwards. And for moving backward, we know the logic, we have to minus 1 add capacity and then modulo capacity. So rear should be equal to rear minus 1 plus capacity modulo capacity, size minus minus. Size will decrease because we have successfully deleted element, that is number of element gets decreased, gets less by 1. Get front, if it is empty there is no front to return, return minus 1, otherwise directly return q front. Rear same, if empty minus 1, return q rear. Bool is empty, so if return what size equal to 0, size was the number of element present. So if number of element present is 0, it is empty, true. If it is not, false. Full size equals to capacity. Capacity is the maximum possible, size is what is available. If available is equal to maximum possible, then surely the queue is full. And if they are both are not equal, then the queue is not full. So this is the logic and approach how to solve design circular DQ. Thank you.